All zero of you. You know, three zeros only add up to zero. Ooh, good point. I think decimal.
Ooh, hello. All right. I'll be taking over Moonlight today. Hey guys, so Josh is out sick today. We have a good crowd today. Love you, love it, love it. Thank you guys. Uh, bunch of people. It's good. Yeah, sold out. We sold out. Thank you guys. Woo! All right. The I don't know the script entirely, but the first half of Moonlight is student pitches. Yeah, the pitches, and we have uh, one person. Oh, okay, we have one person who wants to pitch their idea. Come on up. Woo!
Uh, it's not so much of a pitch, because I didn't know it had to be a pitch, but it's more just talking about uh, chemistry. Because my background is chemistry. Um, so who here? He probably does. Who here knows why water is polar. Yeah. Okay, so because it's yes, yes they are. So the question is, why is water polar? The significance is, if water was not polar, life could not exist on Earth. And what we know, or what most people know about like electricity and magnets and charges, is that opposites repel. I mean, yeah, same charges repel, so positive and positive repel each other, and negative repel each other, and negative and positive are attracted to each other. So two hydrogen atoms connected to an oxygen atom, both hydrogens are positively charged, oxygen is negative, and since positive charges would repel each other normally, why do the hydrogens actually get closer together than they could? Like, if there was a whiteboard and you imagine like an oxygen and a hydrogen on either side, the furthest that those positive charges could be from each other is perfectly on opposite sides. But they're not, they're bent. So I wanted to lead off with this because when I was taking chemistry, I got into molecular modeling, and I was introduced to a program called Spartan Pro. It's written in Fortran because it needs to do a lot of math, basically. And what you can do is make a molecule and then calculate just by placing atoms and connecting them, calculate its energy and its actual position, which is something that, if you've taken very many chemistry courses, is pretty significant. Because the first thing you start learning in chemistry, if you actually get deeper into it, is that everything you were taught before is wrong. So we start out with the simple molecule in the center. Things orbit in a circle around it, filling orbitals. This is very wrong. We go on and we find, we can say molecules are, this molecule is connected to this molecule with a bond, which is represented with a line. This is closer, but still wrong. What the Spartan Pro program allows you to do is actually take a molecule like water, which has some very significant implications for us, and bring it to its lowest energy and tell you what the exact positions of each atom is in the molecule. And if you do that, it will just naturally fall into the position that it really is. But using this program, you can actually see why. The reason why water is the shape that it is because oxygen has extra electrons that are left over after it binds to the two hydrogens. So the rule of 8, if you took a basic chemistry course, the octet rule, every molecule wants to have a set of 8 electrons to fill its orbitals. If you take oxygen 6 and you add 2 hydrogens, you get 8, you fill the orbitals, that's great. When you draw the actual molecule, you have oxygen in the center, you have 2 hydrogens, and then you have 2 pairs, so 4 electrons that occupy the remaining orbitals. And those orbitals aren't just like circles around the thing. They take up physical space, and they cannot overlap with the orbitals of the other bonds. So essentially, they're in the way. So when you have four objects that are attached to something in the center, they form a tetrahedron, especially if they collide with each other. So the reason why water is shaped the way it is and why it's polar is because the leftover negatively charged electrons still have their orbital, they have their space, and they push the hydrogens out of the way, push them down. And you can see that if you look at Spartan Pro. Huzzah. No, I don't have that. Check out Spartan Pro, it's cool. Is the idea. I didn't know it was supposed to be like, oh, business. This is not my specialty. But yeah, I know. I just I'm forced to come here thanks to Gaetan. I didn't know it was like, I would talk about a project for an idea for a business. So I just thought,
Okay.
like a few seconds.
Alrighty. So moving on, any more pitch ideas? Are you guys gonna do the Tony project? The open project? All right, we got another person who's gonna talk about their exciting project.
Woo. Hello. I'm making a social media management platform. No, not this again. So it's basically going to be able to post to your social media profiles from this website. And I'm tailoring this specifically to 42 because they need a social media management platform. And the other ones cost money. And so instead of paying for one, we'll just make one. So it's like being, it's able to handle, like, manage your social media, basically. So for 42, social media management platform, it connects, you're able to log in with your Twitter or your Facebook or any other social media profiles you have, and from there you can, like, schedule posts, you can make posts, and you can look at your analytics, your followers and everything for it. There are other ones, yes, but they cost money. A lot of them are not, like, are expensive, so. Like, for minimum is like $100 per month. To make one, yeah. How much time do we think we can make one? Well, probably, like, we're aiming for like a month for this one that we're making, mostly because everyone's schedule is different. But it shouldn't take too long to make one, because a lot of it is just connecting to APIs and figuring out how to post from that API. There's 4 of us, so it should take probably less time too. Yeah. It will be. Right now, we'll just make it for 42, but hopefully afterwards. What? But afterwards, I hope to make it open source, not charging people. Yes. Cool. I'm done.
Thank you, Kim. Anyone else? Tom seemed excited about presenting an idea. Dan? No, I mean any open projects that you guys have? No? No? Oh, okay. So I'll do one. I'll do mine. Okay. I think some of you already saw that in the back we got a bunch of VR things, and I found this. Well, in the back they have like this turret simulator. And what I want to do is I want to create a VR treadmill. So for those who don't know what a VR treadmill is, it's like an infinite like space for you to walk in a VR world. And I was seeing online the little trackers they use on your feet. They cost around $150, and they could easily be made with an Arduino with a gyroscope module for less than like 25 bucks. So that's my end goal, creating VR foot tracking devices and converting that platform into a VR treadmill. So it should not be that hard to do, but I do have to spend a couple bucks to design it and, do that endless rotational ground that we need to make there. Yeah. Anyone else? Yeah, yeah. So the platform right there actually rotates and moves around because it was built for like a turret gun VR. Yeah, the one in the back. So you could actually, what I'm trying to do is just connect like a harness to it, so you don't fall or trip, and you could move around and just keep walking. Alrighty, I guess that's it, and we're gonna start our presentation. We have Chris and Dan. They're gonna do their interactive AI storytellers. I'll hand it to them.
Okay, guys, as we see, we all sold out today. Yeah, hall is full. People don't have place to sit. So we'll present interactive AI storyteller. So it's based on a couple different technologies. But first of all, let's talk about gist of the project, what it is. So it's about new twist on audiobooks and text-based adventures involving a conversational-driven story. Let's present our team. So this is Chris, this is Dan, we're part of 42. Let's move on. Okay, so immersive AI-powered fiction, what it is. We take the traditional audiobooks, which would be, linear, and we introduce them, multiple plot lines, multiple forks and plot lines. We're doing it by kind of looking in very old-style text-based games, RPG, where you walking through different environments and you solving different tasks and you getting immersed in different experiences and adventures, right? So, yep, next one. Who would be our target? That would be traditional audiobook fans, people who, let's say, they're on a road or they would be in a gym or they're in a kitchen, they cannot use their hands or they cannot use a computer screen, but they would like to get themselves, keep themselves interactive. So they would be audiobook fans, RPG players, casual gamers, so forth. Okay, so market viability, market is huge, considering the size of the audiobooks market and mobile game segments. So if we create on this new genre of audiobook slash game, obviously there is chance for survival, considering also the growth of the NLP and voice technologies. Okay, and we will run a fast demo of couple parts of this product. One is environment for the actions on Google. So that simulates basically Google Home. This thing talks out loud. Maybe we'll be able to hear it. Yep.
Oh, it's you again.
So we'll need to talk to for human, but we can hear what the system says. What's around us?
We're in a plain and sterile room, seemingly lit from all angles. There's a room marked Test Room 2 in front of us. A sharp thing lies to the left of the door, and a dull thing rests against the wall to the right of the door.
Look at the sharp thing.
It's sharp and metallic, like me. It's a short, dull wooden thing. Reminds me of someone.
Okay, getting ready. Go to room
Going
number
toward
2.
room 2.
Can you show inventory? How we deal with inventory? So you can ask
Let's
about.
see, we have a bit, a byte, a kilobyte, and a megabyte. It's a bit. It's 8 bits.
Yep. So it goes back and forth like that. So here we take an advantage of NLP, NLU, right? Can we show API.ai how the questions are intents are formed? To give you idea how is it done on this end. So this is rule-based conversation, right? We basically create an intent, like for example, there is 10 different ways how I can say hello, right? And system will recognize this intent that, hello, welcome intent. So system, we would provide multiple examples, let's say 10 different examples, how you can say hello. And if you will ask something, it will recognize that this is what you want to do, right? And it gives action based back on a webhook that sits on a Firebase, and your program does something. There could be, other intents. You can, for example, intent, I don't know, how old are you, right? I can ask, how old are you? How many years did you live? How many springs did you see? And so forth. So NLP and NLU takes care of these, right? Now, another problem is, do you want to talk more about that? Or?
That's fine.
Okay.
You got 15 minutes.
Yeah, no, we have all the time. So now, a question of default fallback, right? Do we have the console running?
Yeah.
So for default fallback, we have a slightly different system. It will be connected with Flask, with main system. Right now, it sits on a separate Google GPU compute instance. It's small lettering, so we would need to read it for you. So how's it done? We basically took the large corpora of the dialogues, basically from movies, right? Subtitles. And we trained the sequences, question, answer, and so forth. And basically, we took this recurrent neural network and we trained on these sequences. So now it can talk to us some, sweet nonsense. If I will ask, how are you? Just repeat what before that. It will say fine, anything. So just play with it. There is no bad questions. So something's can. What's your name? Bob. Let's not ask these questions because right now we have basically patient with dementia. Dementia, it doesn't remember the context. Like it will forget what it said, like, previous sentence. So if you will ask what's your name in a different way, it will forget, it will provide different name because it's been trained on, on 1,000 different movies, right? So let's, I like silly questions, like, do you like me, for example? Try to play along with system and, try to ask personal questions. Yeah, it does. You can ask what's 42, maybe it knows. I'm sorry. Why am I sorry? Why are you sorry? Which holidays? Right. So we will explain, in a minute how is it done. But basically, there is two problems with this system. One, it's not cognitively adherent, so it does not keep the context. That's one. Second problem, it's not consistent. So if I will ask how old are you in 5 different ways, it will provide 5 different answers. But it's perfectly fine for creating, small talk, chit chat. So then you create a hybrid of two systems. It's more sustainable. So how is it done? It's done with. Oh, you want to go in the front end?
Yeah.
Okay.
Go ahead and Hey, I'll go ahead and talk about what I did for the hackathon and what we worked on. Like we discussed API.ai, which is basically our front end. And that just uses NLP, natural language processing, natural language understanding, and it's natively integrated with Google, so that's always cool because it works with everything. And then, as you saw on the Google console or Actions console, where I was chatting with it earlier, that is the Google Assistant SDK, which synthesizes the voice for you and does all kinds of other fun stuff. And then, so for the back end, we used Firebase. I was using Node.js. I've never done Node.js, but I did things, so that was cool. So that handles all the requests from API.ai and then passes back a response, which is what Google Assistant synthesizes. It also I kind of have a soft storage of all the story information. We're going to integrate that with the database soon. That will be cool. I want to allow us to be able to upload stories and then select them through the agent. And then I'll pass it back to Dan.
Okay, so technologies that are being used on a backend, it's Google Firebase, and also, as we showed before, there is Google GPU compute based on TensorFlow. There is sequence-to-sequence recurrent neural net model being trained on a large quantity of dialogues. So what's the recurrent networks are, right? So what the sequence-to-sequence model is. So feed-forward network, the main problem with feed-forward network that it doesn't have eternal memory cells. It kind of it needs to see whole thing in order to create the decision. Now recurrent neural network, because they're using feeding themselves on each step, they have kind of like memory quality. So what happens if encoder decoder you have a recurrent neural network, which is LSTM, long short term memory network encoder. So it works almost in the same way as they're using it in the translation. Translation by Google by deep neural networks. So at first you feed the network in the LSTM. It will create this vector, which is kind of thought vector. And then they will use this thought vector as entrance input for the decoder LSTM and produce kind of like response. So they use it, for example, for translation. Then I'm translating from, let's say, English to Russian, right? At first I would read the sentence. I would think, what does it mean? And then I would try to say it in Russian if I was reading it in English. So same idea here, sequence to sequence. I would read the input, I would think about it, and then I would produce the output. So this is how it works, encoder, decoder, LSTM. Next. And this is what you saw them, silly answers. We trained this network only for about, I don't know, 15 hours. 15 hours, and the results are getting better and better. We don't have GPU, obviously, in the school, at least NVIDIA GPU that's available for us, so our resources are limited. And this is results that they had. If we will introduce bigger data sets and more computational power, results would get better. Now, going forward, what we would like to do, I mean, ultimate goal for conversational problem is the Turing test. Do you know what Turing test is? Exactly. So, you have this closed wall and somebody's behind this wall, right? And by talking to this person behind this wall, you need to be able to figure out, is it a computer or human? If you're not able to figure it out, then you pass the Turing test, that your system is that good. So that being said, there is another interesting example. It's Mechanical Turk. Mechanical Turk, 200 years ago, there was this awesome chess machine that was able to play chess on very good level. And this Mechanical Turk was invited to different places. And one time it was invited to, the story says, to some king, right? And for some reason, a room got on fire, and midget, jump out of the box and start running. So their solution was actually not to create a super smart machine, but to be able to put the human inside of this box that would fool people, that this machine is that smart. So potential solution could be quite similar. If we, for questions that we know, right, we already have, high confidence what the answer would be. We use a machine, right? Now, if persons start asking some questions that we have no clue about, we did not program by rules our system, we will use this hybrid system. We would use, for example, sequence to sequence, what you saw, but we will let human to rank different answers. For example, can we go back to the sequence to sequence? We can ask, how are you, in slightly different ways. So basically, it's okay. I meant the console, but that's fine. Can you ask, how are you, with question mark and no question mark, for example? That's just an example. What I'm saying that in this model, we can feed the original sentence plus variable, and this variable will provide different random seed. And this way, we will have different, ways to answer this question. And then before we will show it to the human, we can show it to the Mechanical Turk. Mechanical Turk is system done by Amazon, right? So the human will be the ranker of good questions. And if none of the questions make sense, then human would answer. So this way we can scale up the regular customer support systems to let computer to answer 90% of the questions, but then things getting really tough, you put a human behind. And by answering the questions, we create new data sets, we create new dialogues, and we can take these dialogues and now put them in a system. So a system will actually learn from this dialogue. So this system will self-feed in itself and self-proven, self-improving. So this is an idea how to make such system works, especially if you will create not just player versus Mechanical Turk hybrid, but multiplayer game where people will answer each other question, right? Again, you create on this self-feeding loop back in the system where it creates this very useful information for us, information inside of this context. For what context mean? If I'm in room number 1 and I'm asking my guardian agent, where am I, right? It should tell me that you in this beautiful blue room. If I went to room number 2 and I will ask, where am I? It should be able to understand that now there is a different context. I'm in different locality, and that would be captured potentially in these dialogues. Yeah, so that's an idea. That's an idea. This is what we worked on, and this is how we won the hackathon.
So, questions? Oh, we had a demo story that we wrote in less than, 2 hours? And then the one that I'm using right now is just, I set up like some test rooms with a JSON object, and that's our story. But ideally, we would have users provide stories. Any other questions? Yeah? Yeah, no. So the question was, how would you improve immersion since the Google Actions is only has a single voice? You can't have like multiple actors in a scene that voice themselves and so on. And yeah, that is a concern that I had when I was working on this. I was like, well, I mean, we're kind of locked to like these weird plot devices where you can only like hear hear about the outside world from one actor. It's like you kind of have to make up things like, oh, well, you can't see and hear. I'm your only guiding voice, that kind of thing. So yeah, that definitely is an issue, and I would hope that maybe Google would add support for that, or if not, maybe we could have our own thing. Dan might have something to add.
Yes. So yes, that's an issue, and there is couple solutions. Couple solutions that Google SDK provide a choice of 4 voices right now, 2 males, 2 females that you can choose. Yes, you can switch between them. You can switch. Yes. From the very beginning, you can decide what your voice is. Now, there is a markup in this language. There you can input the effects inside of the response. And if you decide to take everything, to do everything yourself, and you want to have your own voice synthesizer, potentially you can dynamically create the sound and put it inside of the response. Instead of text, you would put that response. But that's not that easy to create, to synthesize the voice. I'm not that ambitious, at least.
FT Vocal Simulator, anybody? Any other questions? Yes, Renee? So the question was, are we looking to expand for news stories? And yeah, I kind of answered that a little bit earlier, but that's fine. Essentially, yes. we definitely want to have like a platform where either we can add stories, or other people can add stories, or companies can pay to have stories made for them. And there is potential for content to be produced and published on this platform for sure. Any other questions? Yay.
Thank you.
Alrighty. I guess that concludes Moonlight tonight. I sign out. No, I'm just kidding. Thanks. Next week, actually, I don't know the calendar. You guys need to ask Josh. Next week we'll be here though, Wednesday, from 7 to whenever we finish. Oh, the website should be coming up soon, very soon. Yeah, very, very soon. So keep an eye out for that, because we're really excited for it. Josh worked really hard on that. Thank you. Peace.